Hello everybody, this is Mr. D, and here are the 7 rules for ionic compounds that we go over here in academic chemistry. Rule number 1, always start with the cation and always end with the anion. Okay, the cation is the positive one, the anion is the negative one, so which of these things is correct? Well, here we've got the negative chlorines before the positive magnesium, so no, that's not correct. What is correct is this right here, that. Starting with the positive magnesium, ending with the negative chlorine, that's your ticket. Now, rule 2, there is only one compound anion or cation per compound. And this is about reactivity. So let's say you've got a little phosphorus anion that floats all over here, and you've got several other atoms that come over. This copper comes over and it is positive, so it hooks up with the negative. It's like, yo, what's up, phosphorus? And phosphorus is like, cool, let's bond. We are opposites and they attract. So bam, bond. And then after a little bit, we've got this silver comes along, and you think, hey, there's an extra space there. Yo, copper, what's up? I'm going to just, kind of, bond with this phosphorus as well. And copper's like, well, I want to bond with the phosphorus more, and I'm more reactive. So, and then the silver is like, no, I'm not reactive enough, and it just kind of floats away. And then eventually, another copper comes along, and it's like, yo, I'm just like you. Well, not quite. I've got a different charge, but that, we're both coppers, so this will work, right? And it's like, no, I'm more reactive. And it's like, yo, bro, not cool, not cool. But eventually, another copper comes along, just like the first copper, and it manages to bond. And they're like, I still don't like you. And it's like, well, I don't like you either. And yeah, they really can't push anybody out. And this happens until all spots are bonded, in which case you then have a proper compound. 3, no charge when done. Just like you saw earlier, as long as there is a charge available, it'll keep sending signals out to attract nearby ions. So the negative will attract the positive will attract the negative, and eventually, as the 3 positives for the 3 different silvers all match to the 3 negative for the 1 phosphorus, you're golden. 1 plus 1 plus 1 is 3, minus 3 is 0, so you're set. No more charge, no more attraction. Don't write subscripts of 1, they are just assumed. So as we are sitting here, we have got our, K3P, so we're going to write K3P, but we are not going to write a 1 here. Now over here we got a +2 and a -2, and if you remember, that just means they cancel. And we've got CUS. And so that's done. That's it. That's set. Rule 5, formulas will end in ides. So you've got all these anions, chlorine, oxygen, hydrogen, sulfur, iodine. Well, all of them become ides. Chloride, oxide, sulfide, hydride, iodide, nitride, fluoride. Ide. Okay, so you need to make sure that you're ending your formulas with ides, unless it's polyatomic, in which case just do whatever the back of the periodic table tells you. Do not confuse charge with subscript. Charge is in the upper right, and it's the difference between protons and electrons, resulting in magnetism. And subscript is the number of atoms within that compound, and it is in the lower right. Please do not confuse these. Now, when we talk about subscripts, we're dealing with how many of each of these atoms are there. So, as you can see here, there are 3 magnesiums because you've got a subscript of 3 right here. So this just says, yo, there are 3 magnesiums. If you do that same thought, you've got, okay, there are 4 oxygens, but you've got this 2 here. This 2 not just hits the oxygens because it's in the parentheses, it distributes all the way to the phosphorus, meaning that there are 2 phosphoruses and 2 times 4, because we're distributing oxygens, for a total of 8 oxygens. So here's a picture that kind of shows you that as well. I did this the very first year, so I like keeping it. Rule 7, carbon and hydrogen can be positive or negative. You've got 2 different versions here. We've got carbon hydride and hydrogen carbide. So what's the difference? The difference is the ides are negative. So this carbon hydride, well, that means the negative hydrogens are going to go there. And hydrogen carbide means that negative carbons go there. And that takes care of our various rules.